Hey guys, this is Tristan with Victress Games. I had so much fun making the last tutorial that I'm making another one. In this video, you will learn how to make a simple space game. Nearly all of the objects you see on the screen were generated using only a half page of code. And to see how I did that, let's get started. Okay, to start with, we have a pretty basic scene here. We've got a space background. I'm using the parallax behavior that we saw in the last one. You can check the behaviors of an object, double click on it, and click on behaviors. So I have both the horizontal and the vertical parallax enabled, 0.5. So it'll move half as the background will move half the speed of the foreground. And I have the blue player ship here that we're going to drive, and it has the top-down movement. So let's see. Oh, and the parallax requires you to have a new layer. So if we click on this object, the space background, we'll see the layer is the space background. So we'll get started. There you go. We've got a player and a background. Pretty empty world right now. But let's put some borders around the area we want to make our game. We can do that using the and I currently have one event, which is center the camera. Pretty basic. We're going to, at the beginning of the scene, we're going to do an action, and we're going to use the create multiple copies of an object. This is actually an extension, and it's under other actions. Click on it, and then here's the action. We're going to use this orange block for the outside of our world, kind of define the boundaries of where we can go and where enemies can go. And we're going to start by drawing the top and the bottom. So we need 2 rows. We'll do the top and bottom first. So 2 rows, and they're going to be 23 squares wide, 23 objects wide. We'll just leave it at starting at the 0, 0. We can fill that in. It's not required because the defaults are there, but it complains kind of red if you leave an entry without filling it, so let's fill it in. Amount of space. This is important because between the top and the bottom of our boundaries, it's going to be a lot of space. So let's do 3080 pixels, and let's give it a identifier. You can use this later if you would like. It'll also help us know what this is. Top and bottom border. Alright, and this number, it looks like I picked arbitrarily, but in preparing for the tutorial, I tested this, and this will work well with our block size, the size of our orange blocks. Okay, so let's go. There we go. Beginning of the scene, create the top and bottom border. If we hit preview, you go up, we have this nice type wall, and there's also one 3000 pixels down. Let's add the left and right. So let's do another action. Create multiple copies of an object. Same object. This time we're going to do the left and right side of the map. So we'll do 24 rows and 2 columns. So those are the 2 columns of the left and right side. We're going to start these at 0, 0, and the space will be also 30, 80. And that's space between the columns, not the rows. So there we go. The columns, the left and right are the columns. And then we'll just call this left and right border. Alright. Alright, now we've got top and bottom border, and this new one just added left and right border. And you should be able to see that. There's the top, and there they are. There's the left. And we won't go all the way over there to the right, but it's there. So we've got a border. However, there's no enforcement of this border. It's just a very permeable board at the moment. So we can change that by adding some collision check. And so to do a collision, create a new condition when the ship is a collision with the orange block. So this event happens whenever the ship is in collision with the orange block. Let's do an action called separates. You have to click on an object and then separate two objects. So let's see. Okay, the objects that won't move is the orange block, and we want, so I'll have to click on the blue player ship over here. So blue player ship, separate two objects, and the orange block is the one that won't move. Let's try that. So move the blue player ship away from the orange block. Only this ship will move. Let's see if that works. Cool. It's keeping us inside our world. We can't escape anymore. Excellent. So we have a world that we can travel in, but there's absolutely nothing in it. It's pretty empty. So let's put some things in it. I created, let's do an action, and create multiple copies of an object. We're going to create these, I'm going to put these big gray meteor, these rocks that are going to be floating through our world. And all these assets that I'm showing you were created from the asset store built into GDevelop. The way you get to those is just by clicking Add New Object and then Search Asset Store, and that's where I found this meteor. So I picked one of these. I did do one thing that'll make it easier going forward. I made one change to this object. So if we double click on this object and we click Edit Hitboxes, by default the hitbox is going to be the same size as this black square, and it works for most basic purposes. It's just a great default. But I wanted the hitbox to be a little more precise so that it wouldn't be hitting air. If these rocks run into each other on the corners, they're just going to hit this air. It'll look kind of like they hit nothing. So I use this custom collision mask using 6 vertices. So it's pretty easy to do. So that's the only change I made on that. Let's see. Let's add those. We're going to do the same. We're going to add a new action to the same event, which happens at the beginning of the scene. Alright. Create these, and let's do a lot of these. Let's do 100 rocks. 10 rows, 10 columns. And let's start them at around 400, 400. And let's put some space between them. Let's do 180. And let's call them asteroids. Okay. We've got our border, and now we've got our asteroids all showing up. There they are. We've got our border, and we got 100 asteroids in here, all lined up in a row like stormtroopers. You can see there's no collision with them yet. They are static. They're all uniform, and we can easily change them so that they look more unique. Let's start with changing them. Let's start with changing where they are. Like they're all just exactly 180 pixels apart. So let's do we're gonna have to do a new event. Let's create a new event. This is gonna be something that happens after they're created. So we can't do it, since we're modifying these objects, we can't do it the same exact event that they were created. So the condition is trigger once. This is a really important condition to understand. It basically just means it's going to run one time, and that's what we want. We want to modify these objects one time after they're created. They're created here in that scene. That event, and then here's where we're going to modify them. Let's change position of the meteors. And let's set it to its current position. For the X and the Y. So this is its current position. But we want to change it. I want them to move pretty much anywhere around where they are now, in a little bit in each direction. And a great way to do that is to use a random in range function. And we could do like minus 200 pixels to 200 pixels. Let's just copy that and put it here. So we're going to change the position of each object plus or minus 200 degrees in the X and Y direction. Should we see what it looks like? Alright, so yeah, this is where we are. That's what we just did. Let's look at it. Okay. Well, they're definitely not standing in rows anymore. Well, we do have a little bit of overlap in some cases, and we want to fix that. But it does look a little more natural, doesn't it? They're no longer stormtroopers. Alright, let's see what else we can do to make them look more natural. What if we change their color so they're not all the exact same color? Okay, well that's easy to do. We'll create a new action for the meteors. This is a one-time action. And there's a way to change the color. Tint color is the action. And for the tint, we want this to be random as well. So if you were to pick one single color, it would look like this. Here's red. See there's three numbers. This is the red number, this is the green number, and this is the blue. That's the RGB. And since the R is a big number, that's why it looks red. But we don't want a set number, we want a random number. So we're going to do this with a couple functions. We're going to do random in range, and these values that you see here, they basically go between 0 and 255. 255 is the highest that this could be, and if they were all 255, it would be white. If they were all 0, it would be black. So I want this range to be between 128 and 255. I'm choosing to do 128 to 255 because I don't want the asteroids to look dark. I want them to have more contrast from the black starry background. Okay, we're also going to do some fun things with this. This function is expecting a string, so we're going to have to change that random in range function. This random in range function is going to return a number. We need to give it a we need to convert it to a string. There we go. That's our first one. We need to combine it. Plus basically means connect two strings together. Then of course we need that semicolon still. And I'm just going to copy this because we want to do 3 of these. So copy that and paste, paste. Alright, we don't need the end one. So we got a random number plus that. Oh, we need another plus. That plus that. Okay, a random number between 128 and 255 plus the semicolon, which has to be in quotes because it's a string, and then it's going to add to that 3 times. There we go, this is done. Change the tint of the meteors to a random color. Random red, green, blue. And they won't be dark because the numbers will always be between 128 and 255. And this is going to happen one time. Let's see what it looks like. There we go. We have multicolored asteroids. And you can play with those numbers. There's a lot of different ways to create random colors, which I find fascinating. I may be making an extension to help make it easier for you guys to create like beautiful random colors. But for now, you have random colors. Look, this looks good to me. However, they're all uniform. They're still the same uniform size. Well, let's see if we can change that easily. We're going to change the scale. Scale is a way to change the size of an object. Click on our meteors and scale. Scale the size. And we're going to set them to, you might guess, a random value. But we don't want them to be any number. We have to specify where we want these numbers to be. By default, the scale of 1 is what everything starts at. So I want some things to be smaller and some things to be bigger. So twice as big would be a scale of 2, and half as big would be 0.5. So I'm going to do a random function. Let's do the random float in range. 0.5 to 2. The difference between float and not using float, just random in range. A float means that it can be a number with a decimal point. And so we're going to get values between 0.5 to 2, and it could be pretty much any number in there. between those values. Okay, that's all we have to do. Let's see what it looks like. Alright, here's some small ones and some big ones. I do see a problem though. I will set up collisions, but the looks like the rocks are on top of my the ship is behind them, and that's based off the Z value. So we can easily change the Z value of objects. A couple ways to do it. I could just click on my ship and say you need to be a Z value that's high, 200. Let's see, that should fix the problem. Are they on the right layer? Let's see. Why is that not helping? Let's use a tool to determine what's happening with those, why my ship is flying behind these things, behind the asteroids. And this is a really useful tool that you'll want to learn how to use. It's called the debugger. So it's just like the preview, only you click this bug button, start preview with debugger. So your game will start, and you will need to hit refresh on the debugger. It'll pull a lot of values from the world. Let's look at these instances. So the blue player ship, this one means there's one of these objects here, and this is the instance. See, the Z order is 200. That's what I set it to, thinking it would help solve our Z order problem, but it doesn't help us because GDevelop, let's go look. Big gray meteors, so click on these. See, the Z order is 201 for all of these. So 201. Basically what GDevelop does is it knows that I added that shift first manually, and then when I use this to create multiple copies of an object, it basically went from the highest Z value, which was 200, and added 1 to it. So there's no way I can, basically by increasing this to 200, it just bumped everything else up to 200. So let's set this at 100 for our ship. To solve the problem, we need to set the Z value of these rocks. Here we go. Z order, let's just give them 10. The higher numbers go on top in the world. Okay, we're now on top. Alright, let's try the debugger. Okay, the ship has the order of 100, which we set, and then these 100 meteors have the order of 10, so that's good. So this kind of helps you understand where their position is, some of their rotation values, their Z values, the layer they're on. This is really good information for figuring out what's going on with your objects. The next thing I want to do is animate these asteroids. Let's see if we can make them rotate in place. So there's rotation with a slow spin. Let's start off with a new event. We're going to make them rotate every single frame, so we're not going to add any conditions. But let's add an action. For the big gray meteors, we want to rotate them. Rotate angle. And the speed we want them to spin at, we could just put a number here in degrees per second. But what might be more fun is if we could make the big one spin slowly and the small one spin faster. Just a effect to make it a little more variable. And we have a way of knowing how big they are. It's that scale factor that we set between 0.5 and 2. So let's set the angular speed, the rotation speed, based off that value. And you can do that with the scale function, scale x. You could pick either scale x or scale y, but I scaled them both at the same. So basically it's going to take the value of 10 and it's going to divide it by the scale. So the big scale could be up to 2, so 10 minus 2 will be 5 degrees per second. That would be the big ones, will spin at 5 degrees per second. Or the small guys are 0.5. The scale x is 0.5. So 10 divided by 0.5 actually means that they'll spin at 20 degrees per second, so 4 times as fast. Let's see what this looks like. Okay, it's pretty subtle. They're spinning slowly. Let's see if you can notice the difference between the big ones and the small ones. Let's go here. It's kind of hard to tell, but these small ones are spinning faster. They should be 4 times as fast as the biggest ones spin. Okay, that's a pretty cool effect. The next thing I want to make this world do is let's make these rocks move. They're just kind of sitting here spinning. Let's make them move. We can give them a go to our trigger once function, give them a one-time push, and let's add a force of permanent force. Add a force. Just add a force. And you can choose the X and the Y direction. We actually want to use add a force to an angle. And the angle, just like the other things we've done, we kind of want it to pick a random angle. And we can pick an angle between 0 and 360 really simply, just by using the random function. And if we put a number here, it will pick between 0 and that number. So we will pick 0 and 360. Actually, sorry. We just put 360 in here and it'll automatically be the same as doing that random in range from 0 to 360. So it's good. So each rock will pick a direction to go. And as far as the speed, let's give them a speed that's also based off their size. So I'm going to do 15 divided by their scale. Alright, so random direction and speed based off their scale. And since it's on the bottom of this fraction, the bigger the scale is, the slower the object will move. So I kind of think the big objects are heavy and will move slower, and the small objects will move faster. Also, since I said it's a one-time push, we want to use permanent. So see, it says use with conditions that are only true once, like a trigger once condition. And that's what we're doing. Trigger once, add a permanent force, a random direction, and let's see what that looks like. Okay. We've got a small guy here moving pretty fast, and this bigger guy moving slower. Looks good. I think. Oh yeah, we still don't have any collisions yet. these asteroids are just moving sprites with no collisions built in, so they'll leave the boundaries. They will overlap each other with no understanding that they're touching. So we're going to want to set up some collisions to make that more like the real world. In order to get the most realistic movement of these rocks, we're going to want to use an extension or a behavior called bounce. And let's click on our meteors, behaviors, and there it is. This is one that you don't have to do anything except for add it. You have to make sure that the bounce is here. And let's go do an action. We're going to want it to, I'm going to kind of copy and paste this one. So previously we have the ship in collision with the orange block. Let's make it so that it's the meteors in collision with the orange block. And instead of using this separate action, we'll use the bounce behavior that we just created. So we'll click on the meteor. You always have to click on your object first for these behaviors. And there it is at the top, bounce off another object. Now this is basically simulates physics. It's not as good as using the actual physics engine that's built into GDevelop. I'll do future tutorials on that. But for our purposes, this will actually look pretty realistic and nice. So we're going to bounce the meteors off the orange blocks. Bounce them off the block. And let's do the exact same thing. You can actually have them. You can detect they're in collision with themselves. Meaning, if there's an object that's a rock is in collision with another rock, bounce them off each other. So there we go. I've added these two things just now. Let's test them. Oh, we just saw a collision right here. Let's see if we can find some more. Okay, he's going to hit this wall very slowly. But what's going to happen? Boom! Yes, that looked good. Let's look for some more collisions. That was kind of realistic. Oh, that one looked good. And you can see these small guys are moving faster. That's what we intended with our initial speed setting. We gave more force to the small guys. And I think everything looks pretty good. Lots of collisions happening naturally. The ship is not colliding with them. That's something we need to add. Because we don't want the ship to just fly over these. I need to fly around them. Let's just copy this collision event where we were in collision with the orange block, and let's just change that to the meteors. So now if we're in collision with the meteors, we need to move the ship away from the meteor. Let's see how this looks. Oh, I'm stopped. And that looks good. I can't squeeze through these. There we go. Made it. Cool. So now we have some boundaries. We have a world that has objects in it that are dynamic. They look varied and they're doing different movements. They're spinning. This looks really well. I would say this accomplished our goal of creating a world, a game level that we can now build a game into. Let's see how much code we used. Alright, so here we go. Half page of code, as promised. Let's use this extra half page and see if we can create a game, like a full basic game, just using this half page of code. Let's start by adding a win condition, or an object of the game. And I'm going to use these gold stars And we're going to make this ship collect these. So let's put the gold stars into our scene. I'm going to use the beginning of the scene. I'm going to use this extension, create multiple copies of an object. We'll choose the gold star. And how many should we put in here? Let's do 4 rows and 4 columns. That's 16 total stars. And we'll start them at 600, 600. And we'll put some 600 space between them. And we will call these stars. Let's do that. Let's see how they look. Okay, they're in the world. They're a little small, and we don't have any collisions set up. Let's make them twice as big. Do you have any ideas how we can make these twice as big? Yes, we can use the scale. I don't know why I'm making this tutorial sound like I feel like I'm Dora the Explorer. Let's go ahead and do that. So this is going to be a one-time modification of the gold stars. We're going to scale the x-axis, and you can. I want these all to be the same. I want all the stars to look the same. So let's just make them twice as big. Oh, that's just the width scale. We don't want just the width. We want the full scale. If you just do this, they're going to be really wide. You want to see what they look like? I'll show you. See how they look wide, but we didn't change the height? Let's fix that. Double click there, and change it from scale on the x-axis to just scale. That will change both x and y. And that's how that looks. There we go. That's a good size. Let's do... Oh, we have a collision problem here too. We don't want the rocks to basically block our access to them. That would be not fair, would it? Let's make the rocks stay away. Actually, let's make them bounce off it. So we'll copy one of these bounce events. Okay, the rocks are in collision with a star. Bounce the rock off the star. That should keep them from overlapping. Yeah, it looks good. Oh, the player's still not picking them up. So we need the player to pick these up. Let's do... We can just copy this one, which is a collision event. So if the blue player ship is in collision with a star, what should we do? The most obvious thing is just to delete it. It won't look great, but it will accomplish our goal. Let's see if we can collect a star. Alright, now we have a game goal. There's 16 of these stars. We have to fly around the map to collect them. I'm going to do something that I did in the last tutorial and I like to do a lot, is add the glow effect to these stars. They kind of look kind of flat and not that different from the asteroids. So let's see if we can give a glow effect to them. To do that, we need a new layer. GDevelop will stick the layer at the top. That's where we want it, actually. So we'll call our layer glow. And then to add an effect, click here, add effects, and select glow. Choose the default values for glow. Actually, I think I wanted to... Let's see what the default values look like real fast. So I think I wanted to increase it. Oops, they're not on the glow layer yet. Let's go to where we create them. Create objects on, this is the layer. So we're going to choose the glow layer. Let's see if they're glowing now. Okay, oh, they are glowing, but notice how they're just staying away from me? That's because we're only moving the camera on the layer, on the base layer where the ship is. So we need those stars to move now that they're on their own layer. Let's do that. Basically, we're going to, oh yeah, this is where we keep our camera on the base layer. I'm going to copy and paste that. And I'm going to change the layer. I'll just double click it. Choose glow. Now we have these two events that look almost exactly the same. We are centering the camera on the ship for both the base layer and the glow layer. That should take care of, yep, there it goes. It looks the same, like the stars are staying where they need to be. I'm going to bump up this glow so that they are even more obvious that they're special. Let's go edit the glow layer, edit effects, and let's do the outer effect. Let's try that. Outer effect, go to 20. Let's see what this looks like. Okay, I think it's really easy to see them with their white outline now. Alright, now I've got something that we need to collect, but there's really no danger to this map, and for games to have excitement, well, they don't have to, but it's very common for games to have danger elements that we need to avoid. Let's see if we can add an enemy. Here's a sprite that I edited. I just took this Bush 2 sprite that came in the game asset store, and so it was just a bush, and I used the built-in sprite editor to add some circles. So I added a circle, and then I changed to red color, and I did another circle like this. And then I think I used the paint to fill it in, and that's how I made my my original modification for the eye. I'm just showing how I did it, so let's cancel that change. So now I've got a pretty cool looking enemy. I'm not going to create a lot of these because I don't know what kind of difficulty this is going to add. So we can add it to the map, and let's see if we can make it chase us. I like to use the pathfinding behavior for moving enemies. So if we double click on this, yes, I already have it here. So the pathfinding behavior, that's what I'm going to use to give it instructions on where to move. And how should we do that? We'll just create a new action, a new event. And for pathfinding, the simplest thing to do is set the condition to speed equals 0. You want to make sure you're using this AB speed. This is the Pathfinder action for condition for speed. So in the bush, pathfinding speed is 0. Then start a new pathfinding event. And we want to move to a position. What's the simplest thing we can do? Let's just have it move to where the player is. Copy this, paste, this is the location of the player, the X and the Y location of the player. So it's just gonna, whenever it's the speed is 0, which the beginning of the game is going to be 0, it's going to see where the player is, and it's going to move to where the player is. And it's not going to do anything else until it gets there. Once it gets there, it will stop. And since the speed will be 0, it'll move to it'll figure out where the player is at that point in time, and then move to the player again. Let's see how this works. Think it's going to find us? Oh, it's already on its way. There we go. It found us. And we don't have any events triggering, end of the game or damage. It's just going to try to move to us. If it is blocked, if the path finding can't find a valid path, it actually will stay kind of trapped and won't move until it finds a good path towards you. So there it is. He likes to be where I am. It's my friend, I guess. But this is our enemy. Oh, so what should we do next with this? I kind of like him as a friend almost better than an enemy. But we needed danger for this game, so we're going to make him our enemy. Let's see if we can animate him a little bit more. I think if he rotated, he would look more aggressive. So let's copy what we did with the stars, or the rocks, and let's spin him. Okay, so here's where we're rotating the rocks. You can just copy and paste. This is actually a way to do it, is Control, click, and drag. And there are 3 copies of this rotate object. I'm going to change the object to the bush. And let's just rotate that at about, let's make it go pretty fast so it's aggressive, 300 degrees per second. So 360 degrees would be a full rotation in 1 second. This is a little slower than that. And I did want to do the gold stars as well. I think they would look a little bit more obvious that they're special if they spin fast. So let's do that. Okay, we have our medium speed spinning here and a fast speed spinning on the enemy. So yeah, it looks more dangerous, right? It's creepily crawling towards you. And good. It's not really that smart of an AI. This is like one of the most basic AIs you could do, but it was super easy to do, and it actually looks fairly neat. You know, it's chasing me around. Stop! Alright, what should we do next? Oh, we need to do a condition if our enemy touches us. So let's do that. We don't need to do anything too fancy. Let's just check for a collision. We'll copy this one. When the ship is in collision with the enemy bush, let's change the time scale. Basically, let's freeze time, and this will be obvious that the game's over. So by default, time runs at scale of 1. Scale of 0 is stop time. So let's just let it catch it up to us. See if the time freezes. There we go. I can't move. Everything's frozen. You could put like a game over text if you wanted. But I think we got the basics for this game. I do want to give you one little trick that I found that's kind of fun to zoom in and out of your screen, just as an added tidbit to the this tutorial. Let's start the level. Every time we start this level, I want to start zoomed out and then zoom in. I found a really fun and simple way to do this. We need to start by adding a timer at the beginning of the scene. So we're going to add on to this event. And we're going to reset this timer. The timer will be called zoom in timer. So timers, once you start them, they start at 0 and they count up in seconds. So let's create a new event here at the bottom. Let's check that timer. Let's check the value of the timer, which we called zoom in timer. And we're going to see if it is let's take a look at this. By default, it says the timer, zoom in timer, is greater than 1 second. So that's going to trigger when it's above 1 second. We want it to trigger basically in the first second. So I'm going to right click and click invert. So now it says this condition will happen when it's the opposite of greater than 1 second, so when it's less than 1 second. So for the first second of this timer, and we set the timer at the very beginning of the scene, this action will take place. And let's make the action be changing the zoom. Change camera zoom. 1 is the initial zoom, and we want to start this game, like I said, zoomed out. So super zoomed out would be like a 0 value, and we want it to zoom in to the normal 1. So the trick is we just set the zoom level equal to the timer value. And this is a string. So if it's a string, you always have to put your word in quotes so that it interprets it as a string value. Okay, let's do this. And I do know that we have to do this also for all the layers that we want to zoom on. And so the base layer by default, we also need to do it for our glow layer that we created. Alright, so when the timer is less than, because it's inverted, less than 1 second, set the zoom to the actual number of the timer. And the timer will basically start at 0 and go up to 1 second. So that's a great way to zoom from 0 to 1. And this is what it looks like. I think that's really cool. Anyways, that's just a little tidbit for you. And, oh, I did forget one thing. This little guy, using the Pathfinder behavior, in order for him to go around these asteroids, we have to make sure we give the asteroids the... oh, good. I already did that. But it's important for you to know this. Anytime you're using the Pathfinder behavior, if you want to actually not go in a direct straight line and actually avoid things, you have to give the things you want it to avoid the pathfinding behavior called pathfinding obstacle. And I just leave the default cost. Okay, that's it. We were able to create a game environment just using a half page of code, and then look at that, exactly 1 page of code. We have a basic game. You have an enemy that chases you. You've got an objective. And it's a little bit fun. It could take a lot more to make it into a real game. But this, you can see how this is the basics of the game, and I hope you found it very useful in creating your own games. I'm excited to see what you guys are making, and I always have a lot of fun making these tutorials, so hopefully I'll see you again next time. If you have an idea of what you would like to see, put it in the comments, and I will consider doing a tutorial on that. Thanks a lot. Bye.